Welcome students and participants. In this Dr. Babulal Saraf Memorial National Online Workshop on Innovative Experiments in Physics 2022. यह आयोजन हम राष्ट्रीय विज्ञान दिवस के उपलक्ष्य में कर रहे हैं और डॉक्टर बाबूलाल सराफ की स्मृति में हम इसे आयोजित कर रहे हैं। इसका जो हमारा उद्देश्य है वो विज्ञान के प्रति जागरूकता और जो एक्सपेरिमेंट होता है और इनोवेटिव आइडियाज़ हैं एंड हाउ वी लर्न थ्रू एक्सपेरिमेंट, उसको लेकर हम चले हैं। तो इसकी शुरुआत हम करते हैं। हमारा जो आयोजन है वो शासकीय कन्या स्नातकोत्तर महाविद्यालय उज्जैन एवं IAPT RC9 के सहयोग से संपन्न हो रहा है। कार्यक्रम के प्रारंभ में मैं आमंत्रित करता हूं IQAC कोऑर्डिनेटर डॉक्टर नीता तपन को, वो आए और महाविद्यालय के बारे में जानकारी प्रस्तुत करें। डॉक्टर नीता तपन।
Hearty welcome to all the participants. Government Girls PG College Ujjain has been was established in 1958, and it has been catering to the females students for the last 63 years in quality and excellence. This college is a center for excellence which has been graded this status, accorded the status by the state of Madhya Pradesh, government of Madhya Pradesh, among the 8 iconic colleges. And this is one college which had pioneered itself as early as in 2004 for NAC accreditation, and it earned an A grade back then in 2004. In 2016, it earned an A grade again in the second cycle reaccreditation with 3.19 CGPA, the highest score in Madhya Pradesh in the 17th Standing Committee meeting of NAC Bengaluru, and 4th highest in the country. This college is a multi-faculty college with post-graduation in all the faculties, and it has earned 2 crore rupees from RUSA for the development and renovation works, and it has got 11 crore rupees sanctioned from World Bank under IDP, MPHUQIP plan. This physics department of our college has been working relentlessly for creating and inculcating a scientific temper among the students. And in the third criterion of NAC accreditation, it has been contributing significantly for the innovative tasks. And IAPT RC9 is a regular and a very important collaborator of our physics department and our college. They have been conducting offline workshops on innovative experiments in physics. And since COVID, we have been conducting webinars and workshops on these issues. Today, again, it's a pleasure that our Department of Physics is again collaborating with IAPT to conduct this Babulal Saraf Memorial Online Workshop to celebrate the National Science Day, which continues with celebrations of student activities like poster making, etc. tomorrow. And we are honored to have our guests, Professor Vijay sir, Dr. Uttam Sharma sir, and our guests, resource persons. So I, on behalf of IQAC, Government Girls PG College Ujjain and Physics Department, render a hearty welcome to our guests, the students, the participants, and congratulate the convener of this workshop, Dr. VK Gupta sir, to have this spirit of conducting this event on Sunday and continuing to give his education and online help to the students. I congratulate him and extend a hearty welcome to our press chairperson, our principal, Dr. H.L. Anijwal also, sir. And बहुत बहुत धन्यवाद सर. अब मैं माइक पुनः कन्वीनर और सूत्रधार डॉक्टर बीके गुप्ता सर को सौंपती हूँ. बहुत बहुत धन्यवाद.
Thank you, madam. Now, as I told, we are organizing this event with the collaboration of IAPT RC9. So, I invite Secretary of RC9, Dr. Uttam Sharma, to say few words about the activities of IAPT. Sir.
Resource person of today's online workshop, respected Dr. Y.K. Vijay sir, convener.
Thank you.
Dr. Vinod Kumar Gupta sir, Madam Neeta Tapan, IQAC coordinator, all the staff members, faculties, and my dear students. A warm good afternoon to you all. Under the Azadi Ka Amrit Mahotsav and the National Science Day celebration, Government Girls PG College Ujjain is celebrating Dr. Babulal Saraf Memorial National Online Workshop in association with Indian Association of Physics Teachers. Indian Association of Physics Teachers is a national body with more than 10,000 active members, institutional members, volunteers members, and out of this, the RC0 in this IAPT, the Madhya Pradesh region was allotted a regional council 9. So, on behalf of IAPT central body, the Madhya Pradesh region works as a RC09, and I am being the secretary of this regional council 09. The basic intention and basic motive of Indian Institute of Physics Teachers is to promote scientific culture, especially to motivate students, teachers across the school, colleges, freelancer in terms of physics experiments, as well as they are equally supported with the theory part also. So the pioneer of the Indian Association of Physics Teachers RC09 started from Dr. Velankar, and then this generation moves on, and Dr. Gupta sir is also very actively participating in all the activities of RC09. Dr. P.K. Dubey is our president, and Dr. P.K. Dubey, he is our executive council member, and Dr. B.D. Srivastav, he is our president of RC09. So once again, I would like to congratulate Government PG College Ujjain for hosting this event with Dr. Babulal Saraf online workshop series in association with Indian Association of Physics Teachers. And as a secretary of IAPT, I can assure that we will be always be with the schools and colleges and any type of activity which can promote scientific temperament and inculcate the values regarding this. So thank you very much. So I wish best of luck and congratulate once again. Thank you.
Thank you, sir. Now, before we start the workshop, first I introduce Dr. Y.K. Vijay. So, a brief introduction of Dr. Y.K. Vijay is as under. Dr. Y.K. Vijay did his MSc degree in physics and PhD degree from University of Rajasthan in 1975. He was awarded Commonwealth and ICTP fellowships and spent 1 year in Uppsala University, Sweden. He served as a professor, Department of Physics, Director, Center for Development of Physics Education, and Center for Non-Conventional Energy Resources at University of Rajasthan, Jaipur. Professor Vijay has co-authored over 300 research articles in referred journals, citation over 3,500, H index 30, and over 150 research papers in conference proceedings. He has delivered over 100 invited talks and has co-authored 2 books on basic and computer physics. He has graduated 40 PhDs and advised numerous master's and undergraduate research projects to date. His professional awards include IUMRS Young Research, R.K. Ramnath, IAPT Teaching Aids Awards. He has also developed Electron Positron Accelerator, XRF, CVD, and Positron Lifetime Spectrometer. He has been spent 33 years in teaching and research field of semiconductor thin films and nanoporous polymeric filters. His current research interests are polymer blends for organic photovoltaic cells, design and development of CNTs, polymer composite based gas sensors, and gas separation filters. He is also studying photoluminescence and nonlinear optical properties of nanoparticles doped polymeric composites. He is life member of IAPT, APS, NSI, IPA, RAPT, MRSI, and president of IAPT RC6, as well as Rajasthan chapter of MRSI. He has initiated a mission to set up Innovation Hub, a science gallery to learn basic science principles with fun. All over the country, has set up over 25 so far. So we are delighted to have Dr. Y.K. Vijay with us today. So I invite Dr. Y.K. Vijay for his presentation of the workshop and to say a few words about Dr. B.L. Saraf, because um, we have worked with Professor B.L. Saraf and Dr. Y.K. Vijay has worked for a longer time. So I invite Dr. Y.K. Vijay for his presentation. Dr. Y.K. Vijay.
Thank you so much. It's my pleasure to share some of the work which is related with the innovation in science teaching, which I have learned while I work with Professor Saraf, and that is what I will be happy to share with you. Can you see my presentation? Gupta ji?
Yes, sir.
Is it visible?
Yes, sir. It is visible.
Okay. Thank you. Today we are celebrating Science Day week, in fact, a day in advance, in order to remember the contribution of Professor Babulal Saraf. And I'm really happy that the way he started teaching science to us, learning science through experiments, that is what we enjoy. And Anandam is basically the representation of that enjoyment. Okay. What we like to say is play, enjoy, and learn. And that is what I will be sharing with you, the contribution of Professor Saraf and the legacy which we have learned, which we are carrying forward with our students and teacher fellows throughout the country and abroad. So my presentation is dedicated to Professor Babulal Saraf. Those who are familiar with the name and the picture and like to know more detail, I got a link which you can find on a Google. Vigyan Prasar has made a wonderful film on the contribution of Professor Babulal Saraf for the society. Let us see the journey of Professor Saraf. He born in 1923 December, and he lived up to March 2009, about 86 years. Initial time, the childhood is spent in Madhya Pradesh, Badnavar, Dhar district, and then the youth he spent in Delhi University for his undergraduate studies and postgraduate physics program. During 1945 to 50, he spent time at Agra University, and he was a faculty member there and a colleague of Professor late D.P. Khandelwal, who was the founder president of IIPT. We are celebrating the 100 years of Professor D.P. Khandelwal throughout the year, and several activities are being held. During 1950 to 53, Professor Saraf spent time in USA in the Barter Foundation for his PhD program, and from 54 to 64, about 10 years, he worked with the Department of Atomic Energy, Government of India, at TIFR, Tata Institute of Fundamental Research, Mumbai. And during 65 to 83, he was with the University of Rajasthan, Jaipur. During 84 to 90, he was a visiting professor for Africa, supported from International Center for Theoretical Physics, ICTP, Italy. And 91 to 2002, he was working with the government of Madhya Pradesh at Ratlam in association with Inter-University Accelerator Center, IUAC, and DAE facilities at Indore. And V.K. Gupta ji got in touch with Professor Babulal Saraf during this period, probably. He might be knowing him before, but during this period, he was having a very close interaction. And later on, 2002 to 2009, again, he spent time with IPS Academy, very active time, very energetic time at Indore, where he interacted with Dr. Wellenker and many more colleagues around that area. So from 1975 to 2009, I had the maximum overlap with Professor Babulal Saraf in my journey of 34 years. Okay, because 1975, I passed my MSc from Government College Kota, where he was the examiner. And I interacted with him and could impress my interest for physics. And then he invited me to come to Jaipur and spend time. And that's how I was inducted to University of Rajasthan for my PhD program from 1975 onward. I continued as a staff member from 1980 till my retirement from University of Rajasthan. Let me share with you some academic contribution of Professor Babulal Saraf. In fact, in Delhi and Agra, he was dedicated to do a lot of electronic modules like high voltage, amplifier, oscillators using the electronic tubes and circuit design. He used to work himself in the laboratory for a long time, and uh, he was very instrumental and experimental that way. And in DAE, Department of Energy, Mumbai, what we have learned is he developed a multi-channel analyzer, very special device, along with the counters, so that he could record the spectra online. Okay, and during that time, he had opportunity to go to USA for his PhD program, and there he studied the beta decay process and inner bromester lung, okay, internal conversion process. Okay, so he was a nuclear physicist by training for a PhD program. Then he played with the electronics, okay, as a fundamental uh, devices working with hand. And then later on, during 1965, he came to University of Rajasthan and started developing the teaching uh, interaction with the students and teachers. So he left the fundamental research and moved to teaching basically. He had with the UGC University Leadership Program, Center for Development of Physics Education Program, and even at Ratlam, he established a center by government funding and even with the private funding at Indian Public School, Indore Public School Academy. He set up a wonderful laboratory. He set up several nuclear physics experiments at University of Rajasthan, and students were trained during that period, and over so far more than 300 young students are employed by Department of Atomic Energy because of the contribution of Professor Babulal Saraf at University of Rajasthan in the form of nuclear physics experiments. So he had a similar tradition and set up a laboratory at IPS Academy after retirement, and it's still going on. He also developed a lot of experiments on mechanics and fundamental physics using air track, mechanical oscillators, mechanical wave apparatus, optics, and electronics. And that has been the very inspiring and innovative laboratory at Center for Development of Physics Education. And he started a practice that education institution can design and develop their own experiment and share their experience. And that is what I learned. And I can share with you a very important publication from Professor Saraf is Physics Through Experiment. This is the culture he bought into, particularly with mechanical systems. There were two books. One is on electrical circuits and another Physics Through Experiment Volume 1, and Volume 2 is on mechanical systems, the study of some fundamental processes in physics, and that is a very prominent contribution from Professor Saraf and Professor D.P. Khandelwal. So during year visit of Professor D.P. Khandelwal as a visiting professor during 1977 to 78, both of them worked together and brought out this wonderful contribution. And during that time, the Saraf's contribution was recognized internationally by American Association of Physics Teachers and the ICTP, particularly mechanical system with oscillators with Lissajous figure, one can study the resonance phenomena, and during the resonance, you get the idea that how at resonance the phase relationship is related, and that is the major contribution or the recognition from mechanical system. The resonances analysis was done using such a Lissajous figure, locally designed and fabricated. Well, in order to have my learning, I like to share with the students that what are the fundamental forces: gravitational, electromagnetic, nuclear, and weak. These you do not realize in the laboratory, okay? But the gravitational and electromagnetic you realize. How do you realize them? Okay, attractive or repulsive, that you can really study by doing some experiment. Okay, and realization in the laboratory. All right, in microscopic phenomena. Okay, macroscopic phenomena, we normally study the natural science, but the microscopic phenomena, interaction between the atoms and molecules, we study in the quantum science. And in fact, when we do the experiment, okay, we realize that the quantum science is equally important, and the national contribution from C.V. Raman, Meghna Shah, and S.N. Bose, okay, which is internationally renowned on the quantum systems, and the kind of experimentation which Professor Saraf designed and developed reveal that most of the quantum phenomena can be brought to the visible range of human perception. And that is what I like to share with you through this experimental models. Like the Raman effect is basically the interaction of light with atoms and molecules. Shah equation represents the origin of light from sun and stars, and Bose-Einstein statistics deals with the energy exchange between atoms and molecules. So when we talk about the interaction, okay, for example, Ohm's law, there is the interaction of charge and the rate of flow of charge, the electric field, okay. So there could be a positive charge or negative charge, all right, in semiconductors. So in order to identify charge, you have a very simple setup. You can identify the charge by friction. We have an electroscope, bring the plastic object by rubbing and bring it close to the aluminum foil. You realize that they are separated because the induced charge from the metal gets accumulated there. So, well, the effect of charge is realized in the capacitors, in the currents, and also in the induction, okay, all right, when the flux changes, okay. But the positive and negative charge effect can be realized using such an experiment, that if you have a liquid metal and allow the current to flow, so the electron also flow and ion also flow, and ion is massive, okay. So there is a difference between the rate of flow, and that is what you can realize. So the current flows between these two electrodes, but here you find some depression, okay. What we have done is we have mounted a magnet below, so that the positive charge, which is massive, okay, across this negative electrode moves in a circular path and leads to a circulation, okay. If you exchange these two electrodes at positive electrode, you see that there is a flow of mass, okay. The liquid metal revolves around, All right. At positive electrode, there is no movement because it's only
This shows
the
the
electron
clockwise
motion.
movement when the negative terminal is at the center and the positive terminal is outside.
Well, in the same way, if you have the two electrodes in vacuum, okay, this is a central wire and outside wire, and you evacuate and apply certain potential difference across these two electrodes, this metallic wire and ring. So after evacuation at low pressure, the neutral gas is ionized, and that is what we call it as a plasma, fourth state of matter. So that fourth state is visible. Why it is visible? Because the positive and negative ion recombine and liberate light. Okay, so when you have an ionized state, you have got a positive ions, and the electrons, they are recombining here, okay, and generating light. So the fourth state is visible in the chamber. We call it as a plasma. If you interchange the positive and negative electrode, then the illumination will be more dense. That shows the effect of the massive ion and the electron. Okay. Now the central wire is positive, so the electrons are quickly attracted there. And once the electrons are attracted, ion takes long time to move, okay, slowly because of their mass, and therefore you get a intense plasma around the central wire. So this density difference is because of the mass difference between the positive charge carrier and the negative charge carrier. Okay, the negative charge carrier are basically the electrons, and positive charge carrier are the ions of a given atom when a field is applied or plasma is generated. Well, we can have a mass transport even in the iron foils in the magnetic field. If you have a magnetic field below this petri dish where the iron foils are there, so they move, drift along with the field lines. Well, one can get a gravitational effect by a free fall. For example, this ball, if I lift in this arrangement, okay, and release this plank is connected at this point, okay. So when you have a free fall, the ball should come here, okay, straight down, all right. Vertical. But as the plank is also released, when you release the pan, okay, you will find that the cup comes here and catches it. So the ball was here and it comes into the cup, okay. It looks like it has traveled a parabolic path, but no, the free fall is always a straight line path. Okay. Well, the mass and density is also very important parameter when you apply force, okay. Because of the density, this capsule is floating because it has got partially air and water. So it always floats. Okay, but when you apply pressure to the external vessel, okay, partly the water enters inside, okay, and effective density of the object changes and it sinks. Okay, so the effect of pressure is you are changing the temperature, you are changing the density. All right, and this is what is practically used in the submarine principles. Okay, in submarine, if you fill more water, it becomes dense and it can go down in the water, sea, and when you want to come out, you just throw away part of the water from the storage tank. Well, when I say the coupled oscillators, one can think of coupled oscillators using these magnetic rings, and there is the interaction at a distance in the dynamics. And this is what happens in atoms and molecules when they interact. They don't touch each other. Okay, and still there is a energy transfer. One can have a situation like this, large number of rings, like a Newton's cradle. So this is a magnetic Newton's cradle. Energy transfers to the end, okay, because of the interaction. Well, this is a magnetic interaction or a dipole interaction on a plane, okay, representing atomic configuration.
We have got a model
So these
in
balls
which
are
the
having
ring magnet
magnets
is
below,
attached on
and they are
each
having
ball with
north-south
identical polarity of
polarity,
north-south,
identical
so
polarity.
that the dipoles are interacting.
If there are
The
5 balls,
balls are able to float on a
they
surface
will
of
have
water, and
pentagon
they
symmetry.
arrange themselves in a particular configuration. 7 ball with hexagon symmetry, 5 ball or 6 ball with pentagon symmetry, and when there are 4, they result into a cubic symmetry. If there are only 3 balls, they are having a triangular configuration. So the atomic configuration is also similar to the spherical atoms, having interaction, van der Waals interaction, and organize themselves in different pattern when they are repelling each other.
So in quantum science, you have the atomic configuration, van der Waals potential, Rutherford scattering, Bohr orbital. So all these phenomena, we have the laboratory models which can display these effects. So let me show you a few more, okay, like the crystal defects.
We have a model for solid in 2 dimension where the spherical ball of steel are about 10,000 in number, placed between 2 parallel plates having a spacing around 1 mm. And when we see through, then we see the dense random packing of hard spheres as a model with a lot of defects in it. The grain boundaries, the vacancies, and dislocation are visible throughout the structure. So the solid, it shows a plane, a monatomic plane.
With the vacancies and dislocations, all are visible. For example, we want to show the van der Waals potential, which is repulsive and attractive, has got both nature, that can be achieved using such an arrangement.
We have a small bar pendulum in which there is a gravitational force of attraction at the center, but there is a repulsive force of magnetic interaction that results into a van der Waals configuration, and it comes in equilibrium at certain distance. When you release it, it never comes to the center.
If you change the polarity,
Van der Waals potential is found in crystals. In order to represent that, we have an oscillating magnet between two permanent magnets. So sometimes it finds the kinetic energy is not enough to cross the potential barrier, then it is trapped close to one of the magnets. It can be trapped in a magnet, one magnet or another magnet. Okay, shows a bound electron, and once it is has enough energy, it shows a continuous.
we can have an anharmonic oscillator where the linear restoring force can be modified using the nonlinear part as a magnet.
We have modified the bar pendulum in which the restoring force is due to gravity as well as the magnetic interaction. At the bottom of the bar, we have a magnet oscillating with respect to a fixed magnet on the table. The resultant motion is that it is an anharmonic oscillator because the restoring force
is a combination of the gravity as well as the magnetic. So several such innovations are there, like Raman oscillator we can build, or Raman concept can be demonstrated using such a arrangement. This is an independent oscillator, spring mass system, and this is analogous to the photon interacting with this oscillator. So sometimes it interacts with the phase and sometimes out of phase. That gives you exactly the same behavior as the Stoke or anti-Stoke line as described by Raman. Okay, we call it as a mechanical model for Raman. Right? For Bohr orbitals, we can have this Bohr quantization rule is 2 pi r equal to n lambda. Okay, all right, the first orbit, second orbit, and so on. All right, so that can be realized simply by using a signal generator, giving a signal to the speaker, and then we have got a loop, flexible loop. So when you control the frequency, then you can generate the stationary waves across. Okay, and the condition, resonance condition is when 2 pi r equal to n lambda. As you change n, you find different number of loops in this. This is another one, a mechanical model, which is again inspired by Professor Baulal Saraf, that you are having a really a low frequency oscillator, which is maintained, transferring energy here. Okay, and now energy moves in a clockwise or anti-clockwise and results into the stationary waves within this loop. Okay, so this kind of innovative experiment designed and developed at University of Rajasthan has a citation again at American Association of Physics Teacher magazine, AJP, American Journal of Physics, during 1995. Another important experiment using air track, Professor Saraf has designed, and we can redo it using different smart magnets and generate a frictionless track. And as you change the distance between the two magnets, the potential well changes and the frequency of oscillation changes. Okay. Well, This was another very interesting experiment analogous to alpha decay on a linear track. So this moving object in an oscillating potential, sometimes it can be trapped or detrapped while it is moving, because the friction on this air track is very little. Air is blowing through these tiny holes, and this glider has got a 90-degree angle, so it is self-balanced. It moves in a straight line, and this is an oscillating magnetic field. Still it is crossed. Still it is crossed. Now also, now it is trapped and then detrapped again. Okay, so it's all innovations later on. For example, water molecule, in order to show the molecular vibration, you have got a very simple setup. On a speaker, the water molecule is mounted, and then when you adjust the frequency, at a particular frequency, this mode is excited. At another frequency, the other stretching mode is excited. Okay. And in another configuration, like methane molecule, you can have the torsional mode at one frequency and a stretching mode at another frequency.
ओवरऑल आगे पीछे भी होते हुए दिख रहे हैं.
They are moving up and down, and here they are moving just torsionally. Well, in order to study the Rutherford scattering sort of phenomena, again, we have the magnet and a ring magnet at the bottom, and we can place it at different location and measure the angle of scattering by releasing at release mechanism. Okay, and when we want to change the kinetic energy, we place the release mechanism at different distance. Okay. Well, this is again a plasma state. So let me summarize. The innovation hub we have designed and developed now, we have developed several innovative experiments which can be fabricated. They are working on the fundamental principle of science, basic concepts, okay? And in order to understand the fundamental principle, the apparatus is designed and the parameters are such that they are within the range of human perception, so that you can realize, get a feel. All right. So for teaching, these are the wonderful things for young scientists or engineers, how to design an apparatus and bring the parameters and still maintaining the natural science, the quantum science. Okay, all of these are demonstrative, quantitative, easy to fabricate, and low cost. They are fabricated using the available material. All right. Many such models are designed and developed to improve the skill of making, okay, and developing innovative ideas. The main theme of new education policy, which we are working now, and we have set up by now about 31 innovation hubs all over the country. All right. So this is the method of teaching we need to adopt. Okay, this is a demonstration of a water rocket.
In this video, motion of a water rocket is
So you fill a
demonstrated.
rocket with
The
water
water is filled
and
about
pump it
1
out.
liter in
So as the
a
critical
plastic
pressure is
rocket,
released,
and
this
air
rocket
is
comes out and the
pushed
water falls.
inside using a foot
Okay,
pump.
so there is a mass
As soon as the
variation
critical pressure
principle,
is reached, it
and the rocket
releases
can travel a
and
distance
it
something
can
like
move up
100
to a
feet
distance of
easily.
about 100 feet.
Okay, so the theme is enjoy learning, through playing, and that is what Professor Saraf used to talk about, that most of the concept which you like to teach, there should be some model demonstration, and it should be quantitative, and at the same time it should be easily fabricatable. All right, and it should convey the fundamental science so that the teaching is very effective and you have a long memory with it. Okay, so this is showing you briefly some of the models through which you can learn the fundamental science. Okay, and that is what we are looking forward to. Blessings of Professor Saraf. Okay, and of course the IPT founder, Professor Khandelwal. Okay, and celebrating the Science Day will be useful when we think that we can take this science to the next generation by pleasure. It's not by pressure. Okay, so I like to stop sharing my screen, Gupta ji.
Yes, sir. You can stop if there are some questions.
Was it all communicable?
Yes,
Presentation पूरा
so
चला?
many students have joined it. If there is any question,
Sir, Gupta ji,
yes, sir. Sir, I have
presentation.
one question regarding on behalf of the students.
Sure, sure.
On the air track,
जी,
it is frictionless track, and we study interactions using magnetic interactions.
magnetic
If
interaction.
we use simple plastic balls,
Mhm.
then is it possible to study the collision and measure the velocities of these balls?
Well, there will be other losses, like the sound energy will be lost, heat energy will be lost. So if you like to study quantitatively, okay, interaction between any objects like atoms and molecules, then there should be no contact. Okay, so the
Hmm.
field kind of interaction is the best. Right? The mass is there, but it
Okay.
never generates a sound when there is interaction. It never generates the heat, when there is interaction. Okay,
Okay.
so that's the advantage. In mechanical systems, the two losses we have to consider. Okay,
Okay.
so the time I mentioned in my first presentation with Saraf, I think that is correct. During that time, you were interacting at Ratlam.
Yes, sir.
Okay, so it was my pleasure to share my ideas and themes and
Sir,
experience with Professor Saraf, with
one
all
more
of
thing.
you.
One more question, sir. I want to
Yes,
interrupt you.
sure,
Uh,
sure, sure.
that you have shown that 2 pi r equal to n lambda is studied by
Bohr
connecting
orbital, yeah,
a ring on a
ring,
speaker and
speaker, correct,
adjusting the frequency.
frequency,
So,
correct.
at what frequency we get these loops? If the length of the wire
Hmm.
is changed, keeping the frequency same, then also
Uh,
we will get the loops.
yes, correct, correct. So in the same speaker, you can attach wire of different length. So one of the wire which satisfy this condition 2 pi r equal to lambda will be excited, the other wire will remain silent.
We can connect simultaneously different wires.
Different wires, yes, of different length. So multiple loops can be connected on the same speaker. I will share that apparatus that is with me. Okay. So it's a very relevant question.
To see that apparatus, okay.
Okay. Yes.
So these are very good experiments, and I think the students are definitely benefited by it, as I think most of the students have seen these type of experiments for the first time, as
Okay.
I think, and they have not come across such interaction.
Yeah.
And
So I mean,
so this is the first
certainly,
time.
if it is there is no COVID in place of online, if we are offline, then physically you can see each and every apparatus. Okay, and that's a
Okay.
great pleasure. Once we have innovation hub with Uttam Sharma ji, whatever he is planning, so most of these models will reach there, and a student will have opportunity to see all of them.
Yeah, I am very sure that within a few months, maximum 3 to 4 months, we will have
Innovation hub at your place.
of IAPT, and that will be in the Madhya Pradesh region, RC09.
Yeah,
So
correct.
all the students across the Madhya Pradesh and across the country will come and visit to the innovation hub.
Yeah,
So we are
Sure.
working on that.
Good.
Okay. Any other
Okay.
question? So I think there are no questions. So we proceed further.
Thank you.
And now I invite Dr. Anita Manchandia, Senior Professor, for presenting the presidential address on behalf of the principal.
Thank you very much, Gupta sir.
Namaskar.
First of all, I am grateful to Dr. Uttam Sharma ji and Dr. Y.K. Vijay for sharing their valuable time and experience and knowledge with us and with our participants. I hope participants enjoyed their lectures. फर्स्ट ऑफ ऑल एंड देन अगेन मैं एक बार फिर से डॉक्टर बाबूलाल सराफ जी को नमन करना चाहूंगी कि जिनकी स्मृति में हम आज एक हुए हैं और उन्हीं को याद करते हुए साइंस डे के एक दिन पूर्व हम इस वेबिनार को आयोजित कर पाए हैं। गुप्ता जी का प्रयास बहुत सार्थक रहा है। जैसा कि सर ने बताया, डॉक्टर वाई के विजय ने, कि आनंदम शब्द अपने आप में एक अनुभूति देता है कि जो भी हम काम करें केवल वही काम करें जिसमें हमें आनंद आता हो। यदि किसी काम में हमें अच्छा नहीं लग रहा है, यदि नेगेटिव कुछ वाइब्रेशंस आ रहे हैं, तो निश्चित रूप से हमारी ये कोशिश रहती है कि हम उससे दूर भागने लग जाते हैं। तो हम अपनी एनर्जी उसी काम में लगाएं जिसमें हमें आनंद मिलता हो। आनंदम शब्द अपने आप में ही एक बहुत सुखद अनुभूति देता है। सर ने कई सारी टेक्निक्स बताई यहाँ पर, इनोवेशन इन साइंस टीचिंग। सबसे अच्छी बात ये लगी प्ले, एंजॉय एंड लर्न। ये बहुत कम टीचर आज भी इस टेक्निक को यूज करते हैं, पर फिजिक्स में हम कई बार देखते रहे हैं। ऑफलाइन भी गुप्ता सर ने कई प्रोग्राम्स करवाए हैं, उसमें भी हमें ये नॉलेज मिला है इस चीज का कि फिजिक्स वैसे बहुत कठिन सब्जेक्ट रहता है, नाम से ही डर लगने लग जाता है, पर कई सारी चीजें यदि इजी टेक्निक्स हो, नई नई इनोवेटिव टेक्निक्स जैसे सर भी बता रहे थे अभी, उसके कारण फिजिक्स जैसा कठिन विषय भी हमें आसान लगने लग जाता है। और ये तो हम जानते ही हैं कि छोटे छोटे बच्चे से लेकर बड़े तक यदि किसी प्रकार खेलते हुए किसी चीज को सीखते हैं तो उसे भूल पाना मुश्किल रहता है, वो हमारे दिमाग में रच बस जाती है। चाहे हम आगे पीछे की बातें भूल जाएंगे, पर उसका जो एक खेल में उस चीज को समझना रहता है वो हमारे दिलो दिमाग पर हमेशा के लिए छा जाती है। तो इस तरह से सर ने जो बहुत सारी टेक्निक्स हमें बताई, इजी टू लर्न, हमें सभी को ये प्रयास करना चाहिए, नई नई इनोवेटिव टेक्निक्स डेवलप करने के लिए कोशिश करनी चाहिए कि हम भी इस तरह से कुछ सारे बच्चों को, नॉट फॉर फिजिक्स स्टूडेंट, सभी बच्चों के लिए ऐसा प्रयास करें कि उनके लिए पढ़ाई बोझ न लगे और वे आसानी से खेलते हुए बहुत अच्छे से चीजों को समझ के अपने मस्तिष्क में उसे बिठा सकें। इसके लिए मैं सर का एक बार पुनः बहुत बहुत धन्यवाद देना चाहती हूँ कि हमारे साथ सर पहले भी जुड़ चुके हैं और आगे भी हम उम्मीद रखते हैं कि हम हमेशा सर का सहयोग हमें मिलता रहेगा और सर के सहयोग से हम ऑफलाइन भी, अब ये तो ऑनलाइन था, बस अब ऐसा लगता है कि ये अंतिम होना चाहिए ऑनलाइन वेबिनार। कोविड ये मान के चलें कि जा चुका है, थोड़ा सा कोविड गाइडलाइन को फॉलो करते हुए अब हम ऑफलाइन भी प्रोग्राम कर सकते हैं। तो सर मैं अपेक्षा करती हूँ कि हम बहुत जल्द ऑफलाइन भी मिलेंगे कॉलेज में और आपसे बहुत कुछ हमें भी सीखने को मिलेगा और हमारे स्टूडेंट्स को भी सीखने को मिलेगा। एक बार पुनः सर आपका बहुत बहुत धन्यवाद और वीके गुप्ता सर को बहुत बहुत बधाई कि इतना अच्छा लेक्चर ऑर्गेनाइज करने के लिए, इतनी अच्छी वर्कशॉप ऑर्गेनाइज करने के लिए सर बहुत बहुत धन्यवाद। नमस्कार सर।
नमस्कार, थैंक यू।
Thank you, madam. Thank you very much, Dr. Anita Manchandia, madam. And I must thank Professor Vijay. But for formal vote of thanks, I invite Dr. You joined or not? Dr. Rekha Shahapurkar, madam. Dr. Rekha Shahapurkar, madam. Yes, she has joined. So I am inviting Dr. Rekha Shahapurkar for presenting formal vote of thanks. Madam, first unmute the mic.
Good afternoon, everyone. One and all present here. Honorable Dr. Vijay sir, Director Center for Innovation and Science Teaching, IIS University Jaipur. Dr. Uttam Sharma sir, Secretary IAPT RC9 and HOD Physics SCI Indore. Respected Principal Dr. H.L. Anijwal sir and Dr. Neeta Tapan madam, IQSC Coordinator. Dr. V.K. Gupta sir, Convener and HOD Physics Science Department, and all the students and participants. It is such an honor for me to get the opportunity to thank you all dignitaries. On behalf of the Physics Department, Government Girls PG College Ujjain, I extend a warm welcome to the people in the gathering. I would like to express my gratitude to all esteemed delegates of the workshop for their presence and contribution to make this workshop a great success. I extend my gratitude to our Honorable Resource Person, Dr. Y.K. Vijay sir, to take out time from his busy schedule to grace the event. Thank you for inspiring and encouraging us with your words on this special day. A special thanks to Dr. H.L. Anijwal sir for providing immense support to make the workshop successful. A special thanks to Dr. Neeta Tapan madam for their valuable support. I extend my gratitude to Dr. V.K. Gupta sir to organize a practical-based workshop. I also thank to the students for their cooperation. Finally, I must thank the organizing team, volunteers for working hard for the past few days to make this workshop successful. Thank you everyone once again for making it a great success.
Yeah.
Thank you.
Thank you, madam. So we thank all those who have cooperated us, especially IAPT team, Dr. Uttam Sharma ji and Professor Y.K. Vijay, and last but not the least, Dr. Anita Manchandia madam, her presidential address, जो बहुत अच्छी बातें उन्होंने कही हैं कि हम शीघ्र ही यह चाहते हैं कि ये सब ऑनलाइन तो चलता रहे, लेकिन हम ऑफलाइन
Physical mode.
मोड से भी कनेक्ट हों और
Correct.
सर के जो एक्सपेरिमेंट्स हैं उनको विद्यार्थी लाइव देखें सामने। तो जो पर्सनल इंटरेक्शन है और वो लाइव डेमो, 1-to-1 इंटरेक्शन वो हमारा हो, ये इस आशा के साथ हम एक बार फिर सबको धन्यवाद देते हैं। और जो पार्टिसिपेंट्स जुड़े हैं उनके लिए जो फीडबैक लिंक है वो उनके व्हाट्सएप ग्रुप में प्रोवाइड की जा रही है, तो आप अपना फीडबैक अवश्य दें कि आपका हाउ यू वाज योर एक्सपीरियंस, आपने क्या अनुभव किया, और जो सजेशंस हैं वो उनका स्वागत है, जो कमेंट्स हैं आपके वो उसका स्वागत है। सो आई एम प्रोवाइडिंग द फीडबैक लिंक इन द व्हाट्सएप ग्रुप्स। ओके, सो थैंक्स।
Thank you very much, sir. Thank you. Thank you, YQ Vijay sir. Thank you, Gupta sir.
Good.
Thank you, everyone.
Thank you.
विजय सर, आपसे पीटी के लिए बहुत जल्दी हम।
हाँ, sure. Thank you. जल्दी मिलेंगे।
ओके सर, थैंक यू सर।